This is a video walkthrough for practice 13.1. In each question, we're going to be asked to find each limit or function value if it exists, and we have to keep in mind what all of the notation means. So in number 1, we are asked for the limit of f of x as x approaches negative infinity. Think of your x-axis as a number line. Negative infinity would be all the way to the left. So that means that we're looking at traveling along the graph, and what are the y values of the graph getting closer and closer to as we travel to the left. And the limit is equal to 0 because the y values are getting closer to 0. For number 2, we are looking at the limit of f of x as x approaches 3, and that superscript that is a negative on the right side of the 3 means from the left. If we go to x equals negative 3 on the graph, we notice there's a vertical asymptote there, and there is no actual point on the graph of the function. However, if we travel close to x equals negative 3 on the graph, we'll notice that the y values are getting larger and larger and larger, or tending toward positive infinity. In number 3, we're taking the limit of f of x as x approaches negative 3, but this time there is a superscript plus, which means that we are approaching from the right side of negative 3. So on the right side of x equals negative 3 on the graph, we'll notice that the y values are tending toward positive infinity. In number 4, we are asked to find the limit as x approaches negative 3 in general with no superscript. That means the limit from both sides. And if the limit from the left was positive infinity and the limit from the right was also positive infinity, that means that the limit in general is also positive infinity. If they agree, then the limit is what they agree upon. In number 5, we're asked to find the value of f of negative 3. And it's important to realize the difference between approaching negative 3 and f of negative 3. F of negative 3 is asking us what the y value is at exactly negative 3, and that is undefined. I'm going to skip my equal sign there. I'm just going to say the words is undefined. We usually reserve equals for equals a number. The one exception to that is when we say a limit is equal to infinity. In number 6, we're asked for the limit as x approaches negative 2 from the left of f of x. So let's find negative 2 and approach x equals negative 2 from the left side of the graph. What we'll notice there is that the y values are tending toward positive 1. In number 7, we're looking for the limit of f of x as x approaches negative 2 from the right side. On the graph, if we approach negative 2, but from the right side of the graph, we'll also notice that the y values are tending toward positive 1. In number 8, we are looking for the limit as x approaches negative 2 without a superscript, so this time we are looking for the limit as x approaches negative 2 in general. For this, we need to look at the two one-sided limits. The limit as x approaches negative 2 from the left is 1. The limit as x approaches negative 2 from the right is also 1. So that means the limit as x approaches negative 2 in general is also equal to 1. For 9, we are looking at the value of f of negative 2. This is the value at x equals negative 2. So on our graph, we'll notice that there is a point when x equals negative 2 on the graph of the function, and that y value is equal to 1. And so you'll notice in number 6 through 9, all these values are equal to 1. That is a property of a continuous function. All right, in number 10, we are looking for the limit of f of x as x approaches positive 1 from the left side. So I'm going to get on the graph and approach x equals positive 1 from the from the left side, and we'll notice that the y values are tending toward positive 4. Not what happens at x equals 1, rather, but what are they tending toward? So they're moving toward y equals positive 4. So for number 10, the limit as x approaches 1 from the left of f of x is equal to positive 4. In number 11, we're looking for the limit of f of x as x approaches positive 1 from the right. So this time, if we get on the graph and move toward x equals positive 1, but from the right side, this time the y values are tending toward negative 3. So the limit as x approaches 1 from the right of f of x is equal to negative 3. In number 12, we're looking for the limit as x approaches 1 of f of x in general. If you notice that the left and right side limits for the same value x equals 1 do not agree with one another, that means that the limit as x approaches 1 of f of x does not exist. In number 13, we're looking for the value of f of 1. This is the value of y at x equals 1. So if we find that point on the graph when x is equal to 1, the y value of the function is negative 3. So f of 1 is equal to negative 3. For number 14, we are looking for the limit of f of x as x approaches 3, but from the left side. So I'm going to get on the graph from the left side of x equals 3 and look to see what the y values are approaching, and they are approaching positive 1, which means that the limit as x approaches 3 from the left of f of x is equal to positive 1. In number 15, we are looking for the limit of f of x as x approaches 3, but from the right. So if we travel along the graph of y equals f of x toward x equals 3, but from the right, we'll notice that the y values are getting closer to positive 1. So that means that the limit as x approaches 3 from the right of f of x is equal to positive 1. In number 16, we are looking for the limit as x approaches 3 in general of f of x. If we look at the two left and right limits, the left and right limits are both equal to positive 1, which means the limit as f of x as x approaches 3 is equal to positive 1 as well. If the two left and right limits agree with each other, then the limit in general is equal to that value. In number 17, we are looking for the value of f of 3, and f of 3 is the y value of the function at x equals 3. So if we are on the graph at x equals 3, we're going to notice that there is a separate point on the graph there. When x is equal to 3, the y value is also 3. So that means that f of 3 is equal to 3. In this one, you'll notice that our limits do not agree with the function value, which means that the function is discontinuous there. In number 18, we are looking for the limit of f of x as x approaches 4, but from the left. So I'm going to get on the graph from the left side of x equals 4, and note that the y values are approaching 0. So the limit as x approaches 4 from the left of f of x is equal to 0. And now, in number 19, we are looking for the limit as x approaches 4 from the right of f of x. So I'm going to get on the graph and approach x equals 4 from the right side of x equals 4, and note that the y values are also approaching 0. In number 20, we're looking for the limit of f of x as x approaches 4 in general. So for this, we need to look at the left limits and the right limit, and note that they both agree. They're both equal to 0, so that means that the limit in general is also 0. If the left and right limits agree, then the limit in general is equal to that same value. In number 21, we're looking for f of 4. f of 4 is the value of y at x equals 4. So let's go to the graph and look at the point on the graph when x is equal to 4, and I note here that the y value is also 0. And since both of our left and right limits and the value of y at x equals 4 are equal, we have a continuous function there. The last exercise is asking us to find the limit as x approaches positive infinity of f of x. On the x-axis, the positive infinity is all the way to the right. So I'm going to move toward the right side, and I'm going to note that the graph is continuing to decrease as we move to the right, and so the graph is not headed toward a particular value, but it is getting more and more negative. So in that case, the y values are tending toward negative infinity.